Question 141, which says oils generally have melting point than saturated fats and hence remain blank at room temperature. So we have to select the option which give correct answer for the blanks in above statement. So you all know that oils, they are unsaturated fats. So oils, they come under the category of unsaturated fats. Oils, they are unsaturated fats. Unsaturated fats का मतलब है they have one or more double bonds in their fatty acid chain. So they have double bonds. And because of the presence of double bonds, the fatty acid chain, it bends at double bond structure, and as a result they cannot pack themselves efficiently and densely in crystal as compared to saturated fats. So chain bends at double bond, because of which they cannot pack densely and efficiently in a crystal structure as compared to saturated fat, and hence they have lower melting point as compared to saturated fats. So oils generally have lower melting point than saturated fats, hence remain liquid at room temperature. So the correct answer for this question is option 2. That is question 142. Which of the following are correct with reference to amino acid? A. Amphoteric in nature. Amphoteric means amphoteric are those compounds which can react as acid as well as base. So if we see the structure of an amino acid, it has an carboxylic group, there is an amino group, one hydrogen and an R group, and this R group varies among different amino acid. So when an amino acid is dissolved in water, it acquires a zwitter ion form, that is a dipolar ion having a negative as well as positive charge, and this zwitter ion, it can act as an acid as well as base. Acid means which have the capability to donate a proton, so it can donate a proton and act as an acid. Also it can accept a proton and act as a base. So amino acid, they are amphoteric in nature. Option A is correct regarding amino acid. Option B, that is they are substituted methane molecules. Methane molecules having a single carbon atom, and all the 4 valencies of carbon are satisfied by substituent group, that is carboxylic group, hydrogen, amino group and an R group. So they are substituted methane molecules. This is also correct. Option C, that is serine, is an alcoholic amino acid. In case of serine, the R group is represented by CH2OH. So it is an alcoholic amino acid. Option D, that is amino acid never exists in zwitter ion form at any stage in living cell. This statement is incorrect regarding amino acid, because amino acid at particular pH, they exist in zwitter ion form. So option D is incorrect regarding amino acid. Option E, a dipeptide comprises of 2 peptide bonds between amino acid. Dipeptide में क्या होता है? 2 amino acid, they are linked by a peptide bond. So suppose if I take the example of glycine, there are 2 glycine molecules, and with the loss of water they are joined by a peptide bond. So in a dipeptide, the 2 amino acid, they are linked by a single peptide bond, not by 2 peptide bond. So statement D is also incorrect regarding amino acid. So A, B and C are correct with reference to amino acid, making option first as answer for our question. That is question 143, which says how many water molecules are lost upon combination of trihydroxypropane with 3 molecules of palmitic acid. So trihydroxypropane is actually another name for glycerol. since it has 3 hydroxyl group and there are 3 carbon, so it is known as trihydroxypropane. And palmitic acid, you know that 16 carbon containing saturated fatty acid, so there are 3 molecules of palmitic acid. So in the question it is asked how many water molecules are lost upon combination of trihydroxypropane with 3 molecules of palmitic acid. So when an acid reacts with an alcohol, ester are formed, and the reaction between glycerol and 3 molecules of palmitic acid leads to the formation of triglyceride with the loss of 3 water molecules. This H and OH, it results in loss of 3 water molecule. The trihydroxypropane and 3 molecules of palmitic acid, they get linked by ester bond, so it results in the formation of triglyceride. CH2. And this results in formation of triglyceride. So 3 water molecules are lost, making option first as answer for our question. Question 144 says number of carbon atoms in arachidonic acid excluding carboxyl group is. So you all know that arachidonic acid has 20 carbons including carboxyl group carbon. So in the question it is asked number of carbon atoms in arachidonic acid excluding carboxyl group. मतलब कि हम कार्बोक्सिल ग्रुप के अगर कार्बन को कंसिडर ना करें तो एराकिडोनिक एसिड में 19 कार्बन्स होते हैं, मेकिंग ऑप्शन फर्स्ट एज द आंसर फॉर आवर क्वेश्चन. So let's proceed to our next question. That is question 145, which says choose the odd one with reference to nucleoside. Nucleoside is actually sugar molecule along with nitrogenous base. Sugar molecule, it when bind with nitrogenous base, it leads to the formation of nucleoside. So you know that there are purines and pyrimidines. So the nitrogenous base include adenine, guanine, cytosine, uracil, and their respective nucleoside form is adenosine, cytidine, guanosine, and uridine. So we have to select the odd one with reference to nucleoside. Option first, that is uridine. Uridine is a nucleoside. As you can see in the structure given here, there is a nitrogenous base which is bound with the sugar molecule. And option 2, that is adenosine. Adenosine is also a nucleoside. Option 3, that is cytosine. Cytosine is a nitrogenous base while its nucleoside form is cytidine. When cytosine it binds with sugar molecule, it forms cytidine. So cytosine is odd one with reference to nucleoside, making option 3 as the answer for our question. Option 4, that is guanosine. Guanosine is the nucleoside form of guanine, which is a nitrogenous base, and guanosine is its nucleoside form. Next question.